lecture, I'm going to go through the Linux terminal from a kind of hands-on perspective, and just go through some of the commands you need to be able to run OpenFOAM, but also later on to access high-performance computer system. We're going to use the Sonic supercomputer, and so we need to do that through a terminal. So I'm just going to explain and give some examples kind of in a hands-on manner how to do this, so that the notes will give descriptions of what I'm doing, but I'll maybe just do it from a hands-on perspective. And I'll just look things up here as I go, just remind me not to forget any commands to talk about. So if you're on Windows, you will have installed, or hopefully will install Linux or Ubuntu Linux through this WSL mechanism. So it's basically through the App Store on Windows, you can install something called Ubuntu Linux. So Linux is an operating system or a family of operating systems like Windows. But unlike Windows, where there's just one vendor that makes Windows 9, 10, 11, in Linux, most Linuxes are open source, so they're developed by different groups. So Ubuntu is maybe the most popular version, but there's other ones like Red Hat or OpenSUSE, and they have different, I guess, business cases, each of them. Some of them target supercomputer frameworks, some of them are kind of for home users. So Android, for example, is a type of Linux, but Ubuntu is maybe the most common desktop user interface. So most OpenFOAM users would use Ubuntu. So if you install Ubuntu through Windows, it's basically like a virtual machine that it allows you to run a native installation of Linux directly on your Windows, kind of as an app, and then you can delete it if you don't need it anymore. So in the old days, you had to partition your hard drive and have two different boots, but now you can actually just use this WSL mechanism. So then from Windows, you can then access your Linux, Ubuntu Linux, and Ubuntu Linux has a terminal app, and you just open this terminal like this. If you're on Mac, you can just open the terminal app. So just search terminal, because it is Unix, it actually just has a terminal. Windows has a terminal, but it's a different thing. So there's PowerShell. They're not Linux terminals. They're like Windows terminals, and they have some similarities, but it's not the same thing. So I'm just talking about Linux or Unix style terminals here. Anyway, so this is a terminal, and let's go through some commands you might need. So if you open this up, and it'll be the same commands I'm doing here as the same in Linux. So first of all, actually, can you see that there? Should I make that bigger? Is that okay? Okay. So PWD. So I'm going to type some text and then press enter. And then each of the commands I type, as we remember, if you remember from last day, they're interpreted by a program called shell, or the shell program. In this case, I'm using bash, which is the default shell on Linux. So I write PWD, interprets it, and then it writes something out. So in this case, PWD is print working directory. So this is what is the directory I am currently in. So the way Linux and Unix computers are set up is they're kind of like a tree or an inverted tree. So the first slash is called a root, like the root of the tree. And then this is the name of a folder or a directory at the base of the tree. And then users is a folder, and then Philips C is my home folder. So that's inside a folder called users. And then inside that, there's a folder called desktop. So that's where I'm at the moment. I'm in a folder called desktop, inside a folder called Philips C, inside a folder called users, and that's at the root of the computer. So all of the computer in Linux and Unix is just stored in a folder. So in Windows, you have this registry thing, which confuses everybody. There's none of that. It's all just transparent. It's just a big folder. If you delete everything in that home folder, your computer will stop working. So that's the way it works. If I'm just on Mac, there's an equivalent command on Linux. It can be useful to flick between the graphic interface and the command line when you're getting used to it. So on Mac, you can go open dot, and it'll open a little graphic finder window. On Ubuntu Linux, I'm not sure what it's called. It might be called Nautilus or something, or ChatGPT will tell you. So if you see here, I'm inside a folder called desktop, and okay, I have a teaching link inside that. And you can see I've other folders here. So I'll maybe flick between each of them as we go. Okay, so PWD, that's the current directory I'm in. Next thing I might want to do is I might want to move directory. So to move directory, there's a command called cd. So cd stands for change directory. Normally in Linux and Unix, they use the word directory as opposed to folder. So that's just, normally it's just called a directory. It's the same thing, it's just they call it a directory rather than folder. So I can CD to something, so change directory. So if I want to change directory to a folder, say, I don't know, if I have a folder called my stuff, I can go CD my stuff, and then it'll go inside it. So if I do that here, it'll say CD my stuff, no such file. I have no folder called my stuff at the moment. But if I did, I could go like that. But maybe you want to go up one directory. So up one directory would be called the parent directory. So if I'm in the desktop directory, so I'm here, you can see that's inside, if I go pwd, that's inside a folder called Philip C. So the parent directory of desktop is Philip C. The parent directory of Philip C will be users. And then the parent directory of users is the root, the computer. So if you want to move to the parent directory of the current one you're in, you can go ... So 2 dots with no spaces represents the parent directory. So if I go cd ... and print working directory, now I'm inside Philip C. If I go cd ... again and print working directory, now I'm inside users. Go cd ... again, print working directory, now I'm at the root. If I go and open my graphic interface here, you can see the root is this is my hard drive in this case, essentially. That's just this OWC is the name of the actual hard drive I have in the computer. Okay, so then if I go print working directory, you can see I'm under root. Okay, so we've learned print working directory and CD. Another one that's useful is see what files or folders are in the directory you currently are in. So there's command list, or ls is the command. So that means list what's inside this folder. So if I type ls, you can see that these are all the things that are in the root. So I'm at the root, I go ls, and I can see everything there. It's worth noting here, actually, if I look at the graphic interface, I can see there's applications, library, systems, users. But actually, if I do it from the terminal and I go ls, there's far more things. So the graphic interface will often flag things as hidden, that you can't see them in the graphic interface. So silly users don't go and delete their operating system or something like that. But the terminal, this is maybe one difference that you often have maybe lower level access. Now, there are ways to enable that in the graphic interface, but just to know the difference. Okay, so we go back to CD. Let's go back to where I was. So if I go CD users, press enter. Now I'm back in users. If I ls here, you can see there's shared in Philip C. I'll go CD Philip C. ls. Now I can see I have lots of folders, desktop, documents, open forum, library, music, CD back into my desktop. And I have that teaching link and working directory. That's where I am again. So CD, ls, and working directory. One thing you might notice, if I go back here, oops, cd dot, you might think that I can type very quickly. So I'm just typing desktop. So one of the keys, if you use the terminal a lot, that you'll use more frequently than any other key is the tab key, and tab is autocomplete. So if I type D, press tab, so you can see it flashed because it couldn't autocomplete because there's more than one thing that starts with D. So if I press D again, or not D again, tab again, the autocomplete button again, it'll say, okay, if you want to CD into something with D, you can either go desktop, documents, or download. So if I type E and I press tab, then there's only one completion. So then it'll autocomplete it. Whereas if I go back and go CDO and tab, I press tab twice, and then it could either be documents or downloads. So if I go C, it'll tab to autocomplete. And if I go back, yeah, desktop. So this tab key is one that you will use a lot. Okay, you can also string the addresses together. So you can go cd ... but if I want to go up to the parent of the parent, I can go and I can just string them all together with // in between. So that'll bring me back to the root. I can go cd users tab, Philip C tab, desktop tab, and now I'm back there again. So all addresses I've used so far have been relative addresses. They've been relative to where I'm running the command from, but you can also give absolute addresses. So you can just say, go to this address, not relative to where I am. And the way you do that is you start the address with a /. So that's relative to the root. So I can say cd users, Philip C, documents. So that's not relative to where I am. That's just go to this full address. And you can run that from anywhere. I could go to this again, desktops, and now I'm in the desktop. So you can use either absolute commands that start with a / or relative commands that just are a name or they're ... or something like that. Other things with CD, if you just type CD on its own and press enter, by default, that brings you to your home directory. The home directory is normally the directory that when you open the terminal that you're located in. So in my case, it's users Philip C. I'm not sure in Linux, it might be home, whatever your name is, or it might be home users, I can't remember. So CD on its own with no arguments just brings you to your home directory. And also tilde in Linux or Unix is the home directory. So CD tilde is the same as just CD. So you could go CD tilde desktop, and that's a way to go to your desktop. Or you could go CD / users CD desktop. That's the same thing. So there's a bunch of ways to do the same command. Yeah. If you press enter without pressing anything else, it just goes to the next shell line that doesn't do anything. And if you make an error when you're typing something and you don't want to delete it, you just want to cancel it, you just do Control C. So hold Control on your keyboard, just press C, that just cancels it. And if some command is doing something great, you can just Control C the command as well. Very good. Let me just see if I have a tree command. Do I have the tree command? Oh, yeah. Maybe, I'm not sure by default, but you can, there's a command called tree. Oh, that's too much. So tree will print out the tree structure of all the subdirectories below you. So for example, I think if I go tree here, this is printing out my entire home directory, all my files and everything. So I don't want to do that. But you can, I think -L is the number of levels. So if I just say to 1 level, then you can see this is just 1 level deep from where I am. If I go to 2 levels, you can see that it gives the subdirectories of everything as well. Sometimes that can be useful if you're flicking between the graphic interface and where you are, and you're still getting used to the terminal structure. All right, so that's PWD, LS, and CD. So if CD ... represents the parent directory, so that's in this case the go up one. So a single dot represents the current directory. So it's not useful to do it here, but sometimes you need to refer to the current directory. So if I go CD dot, it just means change directory into the current directory. So that doesn't do anything. So dot and dot represent the current and the parent directory. Okay, so that's essentially how you navigate. So they're the commands you'll probably run more than anything else. Just navigate around a file structure and see where you are, and ls, see what files are there. Okay, so next, manipulating files and folders. So how do we make files, make folders, and manipulate somewhere? Yeah, feel free to jump in with questions as well as I go through this. It's no problem. Or if something's unclear. So the first thing you might want to do is to make a directory, to make a new directory. So there's a command make dir to do this. So I'm going to go call my directory, I don't know. Let's stick with my stuff. Okay, so if I go make dir my stuff and press enter, it doesn't print anything out. If I go ls now, you can see now I have that teaching folder, that teaching link, and I have my stuff. And I can cd into my stuff. And there's nothing in there, and I can see that the address has been updated appropriately, my working directory. And you can see now I have a folder on my desktop or called my stuff, so not too exciting. So the next thing we might want to do is to maybe create a file or remove a directory. So to create a file, for now, and I'll come back maybe to the text editor. I'm just going to create a file with just some text inside it, and then I can manipulate that file. So in the tutorials, I use this Emacs text editor. So Emacs is a old and relatively popular text editor. There's other ones as well. So VI and Vim will come by default on Linux systems. And then Nano is another one. And then there's some other ones as well. So Emacs is just the one that I use, but you can use any text editor. So many text editors will have a command interface. So if I just use Emacs and the name of a file, if the file exists, it will open the file. If it doesn't, it'll just make a file. Ah, excellent. Emacs is installed. So let me give me a second to find out where my where is. I do have Emacs on this computer. I need to check where it is. Gosh. Sorry. So I reset my all my customizations just to make it look the same as yours, but I've obviously disabled being able to use Emacs. Let me just check. I think I have it installed here. Okay, here it is. All right. So let me. You won't have to do this messing around, but this is just that Emacs doesn't come by default on Mac. All right, cool. Okay, so I have Emacs. Emacs, you would just install it on Ubuntu. You don't have to do this messing. In my case, I have it installed in a particular location. So I'm just going to set up something called an alias. So, okay, I can briefly touch on aliases while we're at it. So if there's any command that's particularly long or unwieldy, or you type it a lot, you can make something called an alias. And an alias just means if I type this, then it will do that. That's just creating that alias. So now if I type Emacs, it does what I want to do. All right, very good. So I'm going to go Emacs, my first file, and I'm using the up and down keys to go back through the history of the commands I typed here as well. So I can just write cat, dog, fish, whatever, chicken. So in Emacs, I won't spend a lot of time on it now, but if you want to save files, they are run any command like save or close. It kind of has a weird syntax. So you hold on the control key, and while holding on the control key, you press X, then release, and then press S. So all the time I was holding on control. So the Emacs commands are often you hold control and then press 2 consecutive keys. So control XS is to save, control XC is to exit. So if I ls now, I now can see I have my first file. If I open this up in the graphic interface, I've made my stuff, I've made my file. Okay, not very exciting, but we can make a file now. This is good. So what might we want to do with it? So we might want to copy it. So how do we copy it? I can go my tab my second file. So the cp command is copy. So if I go cp my first file, my second file, go ls now. You can see I have 2 files. It's just copied it. If I open up the second one, you can see it's just the same. Fine. Maybe I can do that again. Copy it to my second file number 2. Now I have 3 files. Very good. So what might I want to do now? I may want to make another directory and then move some files around. So I'll make another directory, my second directory, ls. So I have a directory and then these 3 files. So I'm going to move my second file to inside my second directory. So if you want to move a file, you just use the mv command. Okay, easy enough. I turn back to the terminal here. You can see my files, everything makes sense. Now, a little bit unintuitively, if I want to rename a file, so if I want to rename my second file here, and I just want to call it test .dat. So the way you rename a file is you just move it to a new name. So there is no rename command. It's just you just move the file to a different name. So you just go move my second file to test.tt ls. That's essentially just as renamed. So it's just changed the name on top of it. Very good. And I can move my directory. If I could rename my directory, my second directory, I could change that to my dear like that. So let's rename that. I can move files like test data. I can move that inside my dear. I can move files out. So I can go my dear tab, see what's inside my second file. I'll move that back to here. So dot is the current directory. Or I could go dot to move it up. So if I go my dear, maybe I want to move that to the parent directory. Or yeah, maybe just the parent directory. So I'll move it up to the parent directory. So if I go ls dot, that's what's above. I can see I have my dear, my stuff, my teaching, and then I'm inside my stuff. So let me just go get that again. So my dear, just move that back to the parent directory. Okay. So there's, and once again, you can do relative addresses, absolute addresses, etc. So that's renaming, moving, copying. One thing which is a little bit maybe intuitive. So if I want to copy my directory, so my dear, I'm going to copy it and call it my dear 2. So if you might think just go cp, copy it, press enter. So if you try to do that, it'll say cp my dear is a directory and it's not copied. So if you go cp for a directory, it won't copy it for you. And the reason for that is essentially what cp is trying to do is it's trying to copy the directory, but not everything inside the directory. It's like the directory is just like a pointer or like a name thing. So it tries to copy that, but not everything inside it, and that's not allowed. So you essentially have to tell the copy command that it has to copy the directory and everything inside it. So the way you do that is you give the cp command the recursive flag. So or means recursive. Recursive means go inside. If there's anything inside that, go inside that. If there's anything inside that, go inside that. Like recursive, just keep going until you've done everything inside. So cp-or means copy recursively, and then that means it'll copy the directory and everything inside it. So if I do that, that'll work. But it's fine to use -or with files as well. So I can go my first file to best2.dat. That'll work as well. So you can always just use -or if you're not certain. So it'll work with directories now. Okay, you probably want to delete things, and you will use the rm command to do that. So rm is remove. So if you go remove, you can go remove test2.data. That deletes the file. Simple. One thing to point out, 100% you'll probably make a mistake. You'll accidentally delete a load of files that you didn't want to delete. Unfortunately, there's no recycling bin. So when you delete it, that's deleted. So some people will set an alias up that their rm command is actually a move command to a folder called trash can. And then that's a way to avoid that issue. So just be careful of rm. It is theoretically possible to recover files or certain softwares which will trawl the hard drive, but to be honest, it's mostly gone if you delete it like that. So be careful of deleting your cases and make sure you backups, for example. So the rm command, I can go my rm my dear. So to delete the directory, it says my dear is a directory, and so it didn't delete it. So if we take inspiration from the cp command, we can't delete the directory because that's not deleted everything inside it. So we have to go -or. So that's recursive. So if you want to delete directory, you have to go -or, but you can use the -or on files as well. So I'm not sure what other files I have here. My second file, I can go -or. My second file, I'll delete that as well. That's fine. Later, I'm going to talk a little bit about permissions, but sometimes files can be marked as read-only. So if you go to remove a read-only file, it'll say this is read-only, you can't remove it. So in that case, you can go -f, which means force. So force means delete it even if it's read-only. So remove -or-f means delete even if it's read-only. And so once you've learned a bit about this, if you happen to come across memes for like Linux terminals, lots of jokes around rm.rf, and then you go /, that's your root. So that will try to delete everything in your computer. So it won't, it'll fail here because I won't have permission. I need admin permission, but you can give admin permission with the sudo command. So if you run that, last for my password, if I do that, probably in 10 seconds, the computer will stop working, and then I'll have to reset my hard drive. So don't run that command unless and be careful of copying commands from Stack Exchange. One thing to point out now, which is different compared to like even last year teaching, is ChatGPT and AI assistants are really excellent at Bash and stuff like this. So if you just explain in terrible English, how do I do this? It'll probably understand you and give you the exact command to do it. And it'll explain the command as well. So even sometimes I'm like, oh, how do I find this file and then rename it and do this and this? I just ChatGPT it and it'll normally give up a good explanation from it. But you still need to understand the basic commands. But it's a good way to learn some of these commands, I would say. Okay, so we've done printing directories, seeding around, LSing files. We've made files using a text editor, renamed them or moved them. We've copied them and we've deleted them. So that's pretty much almost everything you need to run an open case. That's all you need. And even for running with high performance computing, that's all you need. You just need to navigate around, move your model onto the computer, tell it to run, and then copy things off, essentially. So that's most is what you need for Linux terminal, unless you're going to be like a computer administrator, which presumably many of you will not be. Okay, so let me just reset up here. So next thing I want to talk about is permissions. So if I type ls, I can see here I have my directory 2 and I have this file. If I ls my dir2, I can ls inside that and I have test.txt. So we've already seen that you can give options to commands. By an option, I mean if after a command you go dash something, that's an option for that command. So the option will change the behavior of the command itself. And then after the options, you'll typically give the arguments. So if I go my first file to a.whatever.txt. So the things that don't have dashes are called arguments for the command. And then anything that has a dash is called an option. So to run a command, they normally will run with either no arguments or some arguments or 1 or 2. And then you can have options to change your behavior. So most commands have options that are available. So ls, you can go -l. And -l will give you more information about the files and folders that or directories you're looking at. Let me just check. There's al as well. Does that do anything else here? Oh, okay. There's al, and it just gives information about the current directory and the parent directory. But again, let me go l. I think there's a way to color it in as well, but I can't remember what the command is. Is it G or something? Oh yeah, you can get add color by adding G and things like that. So there's lots of configurations. But anyway, let me just stick with -l for now. So in this current directory, I have my first file and my directory. So all of this stuff here is just extra information about the file. And a lot of it's related to the permissions of the file. And so I'll briefly go through what these permissions are. So some of this you'll already kind of have an idea of what it's telling you. So my first file here, you can see 1320. You can see the time is obviously 1331. So this is just the time it was last edited. This is the date it was last edited. Oh, this part here. This one here, I'm actually not sure what that one is. And then these two things here are, the first one is the owner of the file, or it's called a user for the file. And the second one is the group that the file's in. So every file is owned by someone, a user of the computer, and that owner or user may have certain permissions for the file. Like I can see my files, but maybe someone else who has an account on this computer, I can't see their files, okay? And then there are groups, and you can be part of multiple groups. So a file can be part of multiple groups. It just shows one here. So you could have some, like a folder that is added to a public group, and that means everyone in the public group can see that file and has certain permissions around it. Okay, and this number here, I'm not sure about either. I should look those up actually. At some point I knew those. So then these things here over here are permissions. So we have 10 numbers or 10 characters here. So I have a slide in this, so it might be a little bit easier to explain. Just by the slide. Yeah, I'm not going to go full screen because it just zooms a pain. Okay, so okay, I actually have the definition of those fields there. So these first 10 numbers that come along here, so we can break that down into various fields. So the very first character, that essentially is a dash for a normal file, a D for a directory, or an L for a link. And that's about it. So it's just, we saw in our case that we have a directory and then we have a file. The next three fields, you can see or W dash here in this case, but it could be something else. They represent the permissions of the user or owner of the file, Philip C in this case, to read, write, and execute the file. So if there's an or, it means that the user can read it. W means that they can write, which means they can edit the file. They can't just see it, but they can edit it. And then the last one, if that was an X, that would mean they can execute it. So if you want to execute a command or execute a file as if it's an executable, it has that permission to be set as an executable. So the first three are for the user owner. The next three are for the group. They're the group permissions. And the last three are the permissions for everyone else, those who are not the user owner and who are not the group. Okay. So in this way, you can see on shared computers that you can set permissions that certain users can see or edit files, other ones within certain groups have different permissions, and then all other people maybe have different permissions after that. And let me see, actually, what are these field 5? Okay, so this field is the number of links or directories inside this. Okay, fine. And then field 8 is the size of the file in bytes. Okay, no. Very good. So if I ls-l, if I wanted to change permissions, so if I look at my first file here, you can see that it's read. I can read and write it, but I can't execute it. Anyone in the staff group can read it, but can't write to it or execute it. And then everyone else can read it, but not write. So if you want to change permissions, there's a chmod is to change the permissions. And the way it works is there's different ways. But say if I want to change the user permissions, so then you go user, and if you want to add permissions, like I want to add the ability to execute the file, then you'll go user plus X. That means add executability. If I go minus X, it's remove executability. If I go plus read, it's add readability plus W, etc. And then I just go to the name of the file, my first file, and then ls again. So you can see now I can read, write, and execute the file. So I think actually, in this case, I don't want to execute it. It doesn't make sense, but it would be, it could be, you could execute it as a program. It wouldn't actually do anything like this. So you can do that to change permissions. You can also subtract permissions. So for example, I can go, so it's user and then group is the other one. So I can go group minus read write. So I can put two of them together. So if ls-l, you can see now the group. If you're in the SAP group, you can't access this file. You can't like read it or anything. And then the last one is other. So I can go other, remove, read, write, but they didn't have write anyway. I could go read, write, execute. They don't have that, but you can see that now I'm as the owner or user, I have read, write, execute permissions, and then everyone else has no permissions. So sometimes this is an issue if you're copying files to your Windows computer, it messes up the permissions and you copy back that the permissions are all messed up. So it's useful to be able to configure the permissions based on that. Okay. Let me see, is there anything else? I wanted to comment on permissions. No, I'm going to keep going. Oh yeah, just one other comment. There is a number convention for permissions as well. So sometimes you'll see 755, and it's like, what the heck does that mean? So there's a kind of shorthand. Well, even though this is short already, it's a different way to do permissions. So you give 3 numbers, and the number corresponds to a certain combination of permissions. So the first number is for the user, the second for the group, the third for the others. So the number 4 means write permission, 2 means read, and 1 means execute. And if you add those up, it's always a unique number. So 7 means 4 plus 2 plus 1, which means all permissions. So 7 will be all permissions, 5 will be read, 4 plus 1. So that would be read and execute. Maybe write is actually 1. We can check actually. And ls-l. Oh, read and execute. Okay, yeah, so it is. So that would make read, write, execute for everyone, and then read and execute for everyone else. So sometimes you'll see people go commands like that. So if you see that, just know that it's different. So 777 just gives this full permissions to everyone, whereas if you go 700, it will give no permissions to everyone else. And let me see. I think if I go 000, then now I can't edit the file, but I think that's not truly Okay, so I think if I try to delete it, it'll say because I don't have right privilege, it just asks me. So it's still asking, I can still do it anyway. So it's not strict for the user. All right, and let me keep going. Text editors, that's fine. We've looked at those. Redirection. I'm just holding enter now. So sometimes it's useful if you have a script that's doing things, that it's useful to print things to the screen. So there's a command called echo to do that. So echo just prints like whatever you tell it to. So sometimes you can put quotes just for spaces, hello world. You can go echo like that. Very good. That's fine. That's a simple command. Sometimes just saying hello, I'm here. Just if you later write a script and you want to know which point it's at. But the reason I want to show it is I want to show something with redirection. So if a command creates an output, you can redirect that output somewhere else. So for example, you can put it into a file. So I might make a file called log, and then greater than, you can imagine it's kind of like catching the output of the first command and putting it into whatever file you give after that. So if I go echo greater than log, you can see that it doesn't print anything to the screen. If I open that log file, that hello world went in there. So you can do the same thing with QWD. You can put that into the log as well, or any command that prints anything, you can put it in the log. If you go greater than, that will add it to the bottom of the log. It concatenates it. So it doesn't overwrite the file. It'll add to the bottom. So if I go that a few times, if I go Emacs, you can see it just keeps adding onto the bottom of the file. So I could put hello world with this, and you can see hello world got added to the bottom. This will become useful. So when we go to run OpenFOAM, we're going to use this icofoam command, and that will print loads of stuff. Like all the residuals get printed to the screen. So it's often convenient to just put that in a log file, and then you can go peruse that at your own leisure afterwards without having your screen blasted with 10,000 lines of text. Let me see. Yeah. Related to that type of redirection, you can also do something called piping. So if you want to run a command on the output from an earlier command, you can use this vertical symbol to pipe the command. So if I go ls-l, I could just put all that in a log. You can see that's just log, right? But if I wanted to say do that, but then look, maybe I have a load of things and I want to only print the last line of it, I can pipe it. So I got a vertical line like that, and that will pass that to the next command. So there's a command called tail. So if I go tail-1, tail-1 will take something and print the tail of that output. So -1 prints the last line of it, -2 will print the last 2 lines of it, -3 will print the last 3 lines, the word 3. And if you don't say, it'll just print the last 10. So the opposite of tail is head. So you could go -1, -2 as well. So that's where you can pipe things, and then you can put all of these together. So I could go tail -1, and then I could put that into the log file. So you can see how you can start to build up commands that go together. So if you have a file that has loads of stuff in it. So actually, where are my files? Add one here. Okay, echo cat. Okay, so there's a command called cat. Actually, not sure why it's called cat. I'm sure there's a reason for it. But cat will just print the contents of a file to the screen. So you can go cat to file, and let's say I want to print the last 2 lines. Then I could pipe that to print the first line. So through combining tail and head, you can pick out a particular line. So if I wanted to print the second last line, I would say use tail to get the last 2, and then head to get the first of those. That makes sense. So you can use commands like that to get to extract out certain lines files. Okay, a lot of these commands you'll see are already like of secondary importance. As I said, the original bunch of commands, just moving and copying and creating files, is mostly what you'll need, but it can be useful to have some of these kind of secondary files as well. So more commands you might find useful. Finding files, this can be useful. So to do that, there's the find command. So the find command, the way it works is you tell it where you want it to search. So if I say search dot in the current directory, or I could give it directory. And then you go -main, because by default, you have to actually, there's different ways you can search for things. You can search by type of file or by type of directory. So I can go -name, and then my file was called test, was it test.dat? Okay, you can see then it'll find it there. So if I go up a directory and I do that, it still finds it. If I go up another directory, my whole computer, you can see it'll take much longer now. It has to search through all the directories to do that. So this is just like brute force searching. It's not like using indexing or anything like that. So find, and ChatGPT would have a good description of this. It has lots of arguments, so you can restrict things by file sizes and file types, etc. Things like that. But it can be useful to use the find command. If I go my stuff, my deer, let me cat the file that's here again. So cat, dog, chicken, etc. So there's another command called grep that's commonly used in Linux, and grep is for finding text inside files. So it's just like find, not replace. It's just the find part when you replace. So if I say look for the word dog in the file test, then it's like yes, it found it. Great. And if I wrote, I don't know, dog with 2 G's, then it won't find it. But it can be useful. grep has options where you can tell it to print out the line it files it on, or how many times it finds it, and things like that. Also, you can pipe together commands. So you could use find, you search for files with a certain name, and then pipe those files to grep to search inside those files for particular types of text. So you go grep dog. Or in this case, actually xargs. So what comes as the output of this is a file, and you want to pass that as an argument. So you have to use this intermediate xargs to pass that as an argument to grep. And then the last related command is sed. So grep, actually the name grep, I think comes from, I can't remember, it's irregular expressions, and then G might be GNU. A lot of the commands start with G, but I'm not actually sure about that. So sed is stream editor. So if grep is the find part of find and replace, sed is kind of like the replace part. So if I wanted to replace all instances of dog with some other name inside a file, you can say substitute dog for a cat, do that globally inside that file. I have to go -i. It's slightly different on Mac to set the Unix version to Linux. So I have to go -i. I think that's just a Unix versus a Linux slight difference. So if I do that, you can see cat got replaced. Very exciting. So sometimes that can be useful for setting up scripts, for example. And the nice thing with the command line interface like this, if you set up a model, you could write a short script to copy that model and use sed to replace like a boundary condition, like the velocity on a boundary, and then edit that and then rerun the model automatically 10 times or something. Okay, so the last thing I want to cover in the last 2 minutes is you can make a file called my script. You don't have to give extensions. Extensions mean nothing in Linux. It's just for the user. If you're like, this is a text file, you can go .text just so you know. Windows really needs them because it decides what program to open up with. But Linux doesn't need them, but it's normally useful if it's a particular type of file. It's useful to give some indication with the extension what it is. So sh might be a script, but you don't have to do that. So inside a script, you can just give a bunch of commands like echo hello world. You can spell it. So now I have a file called my script. If I go to execute that, I can go // that's to try execute file, my script. And it will say permission denied because it's not an executable file. So I'll have to go chmod user add executability to my script. Then if I run that, it says hello world. All right. So a file, any file, as long as you make it executable, you can just put a load of commands in it and then execute it. Obviously, be careful if you're moving to deleting things that you don't accidentally run and delete a bunch of things that you don't want to delete. And then one last thing to mention is I don't think I use it much, but you can use things like wildcards. So if I go test star, that would delete every star is just means it's a wildcard to represent any character. So if you have any file that starts the test and has any number of characters, including no characters after that, that would delete that. So they're called regular expressions. So there's ways you can pick, like, for example, only certain letters and excluding letters, and you can make very long, complicated regular expressions to search for particular things. Okay, that's pretty much it. That's all you need to know about the terminal. So yeah, that's me done. Oh, this was the exam. This is the exam actually last year. There was a question. This was a question 19. It was, here's these commands, just write the output of those commands. So this is that's a typical type of question, I suppose. You can get this exam paper online on InfoHub. So if you can't, let me know. You should be able to get it. But just to show you what type of questions you can expect to be asked. All right, thanks so much.